What is up, guys? Welcome back to the YouTube video. This is page 4 of the review. We skipped page 3 because it's really most of the same from page 2 and page 1. So if you're struggling on page 3, send me some emails. We're skipping to page 4 so that we can start on the hard part, in my opinion, which is proofs. So proofs are really fun. I love them. Ignore me as I change the camera again. We are going to work on some proofs together. Now, I love proofs because they force you to use your mathematic intuition, to look around and try some stuff. It's okay in a proof to try some stuff and be wrong and erase it and try again. That's okay. So today, I'm going to show you guys probably the fastest way to do these proofs. Now, these are fill-in-the-blank excuse me. These are fill-in-the-blank proofs, so they're not like as tough. But there could be either version on the test, so you need to be ready. All right. Without further ado, I'm going to do just one of these proofs. I'm only going to try the top one. I'm going to leave the other two for you guys to practice. I would like you to try them on your own. You have to try them and then look back and see in the key, if maybe what you did was correct or incorrect. So, without further ado, first thing we always do in a proof is write our givens. So in this case, we're going to be writing our givens. We know that AB is parallel to DC. Let me see, can I zoom in a little bit? Yeah, there we go. AB is parallel to DC. That's one thing I knew was given. The other given was angle B is congruent to angle D. Beautiful. All right. Now that I'm looking, I know these lines are parallel. It helps me all the time to draw what I know on my picture, because really when I'm doing the proof, the intuition I gain is from the picture I draw. That's just me personally. I think it works best for a lot of people too. So these lines are parallel, so I'm going to draw this in AB and DC. These lines are parallel. Oh, lo and behold, when I do that, I notice a transversal is formed, a parallel lines cut by a transversal here, okay? And that's why this next statement is about angle 1 is congruent to angle 2. We know that angle 1 is congruent to angle 2 because these are alternate interior angles. So I would write that here. Alternate interior, or maybe just alternate interior angles is also fine. Very cool. And the reason how I knew this was the reason we could use, is only because this is a way, using what I know so far, to show that angle 1 is congruent to angle 2, and that's what this step required. So it was just one of the ways. There's not a lot of other ways for this particular example, but, in other proofs, in a fill-in-the-blank proof, it could be something else. So, anyways, AC is congruent to AC. We know from class that this is called the reflexive property. And I said this comes up a lot in triangle proofs, the reflexive property. And if you want to be 100% accurate, it's really the reflexive property of congruence. Because the reflexive trait is not of the triangle, it's of the congruence itself. Congruence itself is a reflexive relation, you might say. So, anyways, we see that AC is congruent to AC. This is because the congruency sign acts like a mirror, and it sees its reflection on the other side. It sees its own identity. And of course, it is itself, so we would call that the reflexive property. All right. Here we notice triangle ABC is congruent to CDA. And then there's a blank here, and it says congruence. Okay. This is the whole point of learning the methods we've talked about so far. Side, angle, side, angle, side, hypotenuse, like. The reason we've learned these methods is that they are congruency methods. Congruency methods. The reason these methods exist, they are kind of like shortcuts for showing that triangles are congruent. So, basically, this blank is saying, which of these do you think it is? Well, if we look back in the proof, we see that we've said something about an angle. Very cool. So I've drawn that in here. Something about an angle. We've seen something about a side. There's a side right there. So let's see. So we said B is congruent to D. Sorry, I didn't draw that in. B is congruent to D. That's something about an angle. Then we saw 1 is congruent to 2. That's something about an angle. All right. And then we said this side is reflexively congruent to itself. That's something about a side. So this is a two angles one side, but the side is not included. It's outside of these two angles. That would be an angle-side congruence. I'm leaving my side out to show that it's not between these two angles. This is an angle-side congruence. So, finally, we get the result, which we know will go in the last blank. We know that this here means, and just so we know, this means corresponding parts of congruent triangles are congruent. Something very good to write down. Corresponding parts of congruent triangles are congruent. This is what CPCTC means. Very, very cool. Since these triangles are congruent, we just showed this using angle-side congruence. We know also that BC and DA must also be congruent. We know this because of the way the triangles are written. We see, look, BC and DA are in the same order, which means they're corresponding on those congruent triangles, and consequently, we can write our final statement. BC is congruent to DA because corresponding parts of congruent triangles are congruent. All right, these next few proofs are very similar, but you have to look back and think back to the other geometry things we've learned. In this case, you'll need to know something. Let's see, maybe I'll give you a hint. You're going to need to know what angle bisectors do. Okay? In this one down here, you're going to need to know what vertical angles are. So I'll leave that over here. You're going to need to know what a vertical pair is that we talked about on the last couple pages. All right, so without further ado, try those proofs on your own. Look in the key for help if you need it. Email me if you have questions. All right, that is all for this video. Catch me again on the next one.